Next is the stoichiometric calculations. And the stoichiometric calculations involves the calculation that we can make using the complete chemical equation or a balanced chemical equation. The term stoichiometry, all of you familiar with the term stoichiometry? It's a Greek word derived from stoichion and metron. Two words are there, two Greek words combined to form that word stoichiometry, which means the measurement of elements. Okay, and using the stoichiometric data or the stoichiometric coefficient in a balanced chemical equation, we can predict the product, or we can predict the amount of product obtained, or we can predict the amount of the reactants in order to require to obtain such an amount of product. Okay, let's look. Stoichiometry, it's derived from two Greek words, stoichion and metron. Stoichion means element and metron means measurement. And it involves the calculating masses of reactants and products in chemical process. And this type of calculation, that is the stoichiometric calculation, helps to calculate the amount of reactants and products during a chemical process. Let's look at the example. CH4. What is CH4? Yes, methane. Combined with oxygen, we get carbon dioxide and water. And this is the combustion of methane. And during the combustion of methane, we know methane is a hydrocarbon. During the combustion of methane, we get the product carbon dioxide and water. And this one is a balanced chemical equation because in both reactant and product side, all the atoms are similar. So it's a balanced chemical equation. Here in the reactant side, one carbon, product side one carbon, and here 4 hydrogen atom, and here also 4 hydrogen atom. Here 4 oxygen atom, here 2 plus 2, 4 oxygen atoms are there. So it's a balanced chemical equation. We can say these coefficient, here no coefficient is there, but we consider as 1. And here the coefficient is 2, here 1, here 2, and these are called stoichiometric coefficients. That is the coefficients obtained in a balanced chemical equation, that is called what? Yes, stoichiometric coefficient. Here we can say the molecular mass of methane, we know the carbon atomic mass 12 plus 4 hydrogen atom 16. So we can say 16 gram methane combined with what? 2 O2. 1 O2 means what? Oxygen, atomic mass of oxygen is 16. So here 2 oxygen molecules are there and 2 oxygen molecules. 1 oxygen molecule 32. 2 oxygen molecules 64. It combined with 64 gram carbon, we get what? 1 carbon dioxide. That means 44 gram carbon dioxide and 2 H2O. 1 H2O means 18 gram, 2 H2O means 36 gram. Okay, so we can read like this. 16 gram methane combined with 64 gram oxygen, there's a combustion, we get what? 44 gram of carbon dioxide and 36 gram of water. Or we can say like this, here 1 mole, in the case of mole we can say 1 mole methane combined with 2 mole oxygen, we get 1 mole carbon dioxide plus 2 mole water. Or if we consider in this liter, if we take 1 liter methane, it combined with 2 liter what? Oxygen, we get 1 liter carbon dioxide and 2 liter water. And these are derived from this stoichiometric coefficients. If we want to find the amount of oxygen required to produce or required to compass 32 gram of what? Methane. How can we calculate? Yes, we can calculate that measurement using this stoichiometric coefficient or using this balanced equation. For example, here 1 mole methane. 1 mole methane means 16 gram methane needs how much oxygen? Yes, 64 gram of oxygen. If we want to compass 32 gram of methane, 32 gram methane means how many moles? Yes, 32 gram methane means, yes, 2 mole, 2 mole. 2 mole needs how much? How much? Yes, 64 into 2. 64 into 2 gram oxygen. Okay, so it's highly applicable in case of manufacturing of chemicals. Okay, if we want to predict the products or the amount of product obtained by reacting that much or any quantity of the reactant, we can measure using the balanced chemical equation. This is stoichiometry coefficient and stoichiometry. Once more, stoichiometry is formed by two Greek words, stoichion and metron. Stoichion means element and metron means measurement. Yes. And stoichiometry is concerned with calculating the masses of reactants and products in chemical process. Let's do a problem related to stoichiometry calculation. The problem is this: calculate the amount of water produced by the combustion of 16 gram of methane. Okay. First of all, we want to write the balanced chemical equation as per the question. Once more, what's the question? Calculate the amount of water produced by the combustion of 16 gram of methane. Okay. First write the chemical equation. Methane we know CH4 and combustion means reaction with oxygen. Combustion we get what? Carbon dioxide and water. This is the balanced equation. Now what's the mass of methane here? Yes, CH4 carbon 12 plus 4 hydrogen. So 12 plus 4, yes, 16 gram, 16 gram, right. And here what's the mass of water here? H2O, 1 mole water means 18 gram. Here 2 water molecules are there. So 18 plus 18, yes, 36 gram. Or we can say 1 mole methane produce 2 mole water as per the stoichiometric equation. Our question: calculate the amount of water produced by combustion of 16 gram of methane. 16 gram of methane numerically equal to 1 mole. And here the 16 gram methane produce what? 1 mole methane produce 2 mole water. Okay, 1 mole methane, 1 mole CH4 produce 2 mole water, 2 mole H2O. And the mass of 1 mole H2O is what? 1 mole H2O equal to the molecular mass of water. It's 18 gram. So 2 mole H2O. 2 mole H2O equal to 18 into 2. Our answer is 36 gram. So as per the equation we can say 16 gram of methane during combustion produce 36 gram H2O. Okay. Next question. Calculate the mass of oxygen required to produce 240 gram of magnesium oxide by burning. Once more, calculate the mass of oxygen required to produce 240 gram of magnesium oxide by burning. And we know the metal magnesium on combustion. Combustion means, yes, reaction with oxygen, we get magnesium oxide. And as per the question, first of all, write the chemical equation. Not only the chemical equation, but the balanced chemical equation. Okay. So, Mg, magnesium, combined with oxygen, we get what? MgO. MgO. And here our question is to find the mass of oxygen required to produce 240 gram magnesium oxide. And here no need to consider the magnesium, only we want to consider the oxygen and magnesium oxide. And here 1 molecule oxygen O2, what's the mass? Yes, 16 into 2, that is 32 gram. 32 gram oxygen combined with the magnesium. 2 gram magnesium means 1 gram means 1 mole, that is 24, some atomic mass of magnesium. And 2 mg means 2 into 24, that is 48. And here we don't want to consider that magnesium because our question is to find the amount of oxygen in order to produce what? 240 gram of magnesium oxide. Okay, so 30 gram of oxygen produce how much magnesium oxide? What's the molecular formula of magnesium oxide? Magnesium, what? Magnesium atomic mass 24 plus oxygen atomic mass 16. So 16 plus 24, what's the answer? 6 plus 4, 10. Then 2, 3, 1, 4. So 14. 1 mole MgO means is 40 gram. Here 2 mole MgO means what? 2 into 40, so 80 gram. Okay. So as per the balanced equation, we can write like this. 32 gram oxygen needed to produce 80 gram magnesium oxide. Okay, here this magnesium, we didn't consider the magnesium because our question is to find the amount of oxygen alone. Okay, so 32 gram produce 80 gram MgO. So our question, how much oxygen required to produce 240 gram magnesium oxide? So in order to find X, what we do is cross multiplication. X is equal to 32 into 24 divided by 18. 32 into 24 divided by 18 and we get the answer as 96 gram. And we arrived the answer using this the balanced chemical equation or by the stoichiometric coefficient. Is it clear? So we can say that 96 gram oxygen required to produce how much? Yes, 240 gram magnesium oxide. Okay. Next one is the limiting reagent. The word itself says limiting reagent. What is limiting reagent? Yes, the reagent which limits a chemical process. That's the limiting reagent, simply. We know in a chemical reaction, the reactants changes to get what? Product. And sometimes there are more than one reactants are there in order to get the product. If there are more than one reactant present, the reactant which consume first or the reactant which consume first or the reactant which consume fast is called what? Yes, limiting reagent. For example, if we want to prepare carbon dioxide, we know carbon and oxygen combine together to form what? Carbon dioxide. 10 liter carbon combines with 5 liter oxygen, we get X amount of carbon dioxide. And in that reaction, maybe the oxygen complete first or oxygen finished first. So we can say oxygen as the limiting reagent. Okay. So what is limiting reagent? Yes, the reactants which gets consumed first or limits the amount of product formed. Okay, the reactant which consumed first that determine the amount of product formed. So we can call us what? Limiting reagent, which limits the rate of the reaction or which limits the reaction speed. That is called what? Limiting reagent. Using the stoichiometric coefficients or a balanced chemical equation, we can also find which one is the limiting reagent during a chemical reaction or how much reactant left after a chemical process. Such things we can find using stoichiometric coefficient. Okay, once more, the limiting reagent means the reagent or the reactant which consumed first during a chemical reaction or which limits the reaction, the chemical reaction. Okay, that is limiting reagent. Let's do problem based on limiting reagent. Okay, look at the question. 28 gram nitrogen mixed with 12 gram hydrogen to form ammonia as per the chemical equation N2 plus 3H2 gives 2NH3. We know this is the formation of ammonia by Haber process. Yes, what is the limiting reagent? And here two reactants are there, nitrogen and hydrogen. We want to find which one is the limiting reagent. Okay, yes, rewrite the chemical equation. N2 plus 3H2, we get what? Yes, 2NH3. According to the question, 28 gram nitrogen is there. Okay, 28 gram nitrogen is there and 12 gram hydrogen. 12 gram hydrogen is there. 28 gram nitrogen and 12 gram hydrogen is there according to the question. And here our question, according to this amount of nitrogen and hydrogen, which one is the limiting reagent? Okay, look at this. N2, one molecule of nitrogen. N means atomic mass 14. So N2 means what? Yes, that's 1 mole or we can say it is what? 28 gram. And here 3H2. 1H2 means 2. That is hydrogen molecule. So 3H2 means what? 6 gram. So as per the balanced chemical equation, we can say 28 gram nitrogen needs only 6 gram of hydrogen. As per the question, 28 gram nitrogen is mixed with 12 gram hydrogen. So here 12 gram hydrogen is there, which is excess. Yes, 6 gram hydrogen excess. So which consumed first? Yes, nitrogen consumed first, and by completing the amount of nitrogen, the reaction stops. Or we can say nitrogen limits the reaction. So here nitrogen is the limiting reagent, N2 is the limiting reagent. And what's the amount of hydrogen left out? Yes, 12 minus 6. What's the answer? 6 gram. Is it clear? These are the types of questions based on limiting reagent. Once more, the limiting reagent means the reagent or the reactants which consumed first, or which completes first, or which limits the rate of a reaction, or which limits a chemical reaction. That's called what? Yes, that's called a limiting reagent. And from the balanced chemical equation, we can find the limiting reagent. Okay. Next is the terms related to concentration. We use various terms in order to express the concentration of solutions. Concentration, we know, it's what's concentration? Yes, number of moles or number of solute present per unit volume of a solution. That's concentration. There are several terms used to express the concentration. And some of them are mass by mass percentage, then mass by volume percentage, then volume by volume percentage, parts per million, then what, mole fraction, molality, all these are some terms. And we want to study 4 important terms in order to express the concentration of solution. And first one, mass percentage or weight percentage. Second one, mole fraction. And third one, molarity. And fourth one, molality. Okay, these are the 4 terms. Once more, which are they? Mass percent or weight percent, mole fraction, molarity, molality. Okay, let's check one by one. The first one, mass percent. And mass percent is the ratio between the mass of solute to mass of solution, okay, into 100. So percentage, so multiplied with 100. For example, if we have 10 kilogram of sugar solution, okay, solution 10 kilogram of solution is there, 10 kilogram. In that 10 kilogram, 2 kilogram of sugar is there, okay. So amount of sugar is equal to 2 kilogram. So we can find the mass percentage is equal to mass of solute. Mass of solute means here mass of sugar, that is 2 divided by mass of solution. Total mass of solution is what? Yes, 10 into 100. And we get the answer what? 20%. So we can say that solution is 20% concentrated. That means out of 100, 20% is what? The solute. Is it clear? That's the mass percent. Mass percent is one of the terms used to express what? Concentration. Mass percent equal to mass of solute divided by mass of solution into 100. We know the solution contains 2 components, the solute and solvent. The substance which present in small quantity is called what? Solute, and the substance which present in bulky quantity is called what? Solvent. And a solution can be obtained from combining these solute and the solvent. Okay, so mass percent equal to mass of solute divided by mass of solution into 100. Next one is the mole fraction. Mole fraction is represented by the symbol chi. Okay, this is the symbol in order to represent the mole fraction chi. And here the mole fraction is the ratio between the number of moles of a particular component to the total number of moles. For example, we have a solution containing 2 components A and B. 2 components are there, A and B. Na be the number of moles of A and Nb be the number of moles of B. If we want to find chi A, what is chi A? Yes, chi A equal to, yes, Na, number of moles of A divided by total number of moles in that solution, Na plus Nb, that is chi A. Then also we can find chi B. Chi B is equal to Nb divided by Na plus Nb. So we can say the mole fraction is the ratio between the number of moles of a particular component to the total number of moles. Okay, the number of moles of a particular component to the total number of moles. That is called what? Mole fraction. And sum of mole fraction of all components in a solution numerically equal to 1. That means here two components are there, chi A and chi B. And the sum of mole fraction we can write like this, chi A plus chi B equal to 1. Okay, suppose our solution contains three components, chi A, chi B, chi C. Then the sum of chi A, chi B, chi C, that is chi A plus chi B plus chi C numerically equal to what? 1. Okay, that is the sum of mole fractions of all components equal to 1. And how it is possible? Yes, look, chi A, here what is chi A? Yes, Na divided by Na plus Nb plus what is chi B? Again Nb divided by Na plus Nb. So we can, the denominators are same, so we can write as Na plus Nb divided by Na plus Nb. Denominators and numerators same, so answer 1. Is it clear? So we can say the sum of mole fractions of all components is equal to 1. Suppose it contains 10 components. Then chi 1, chi 2, chi 3, etc. up to chi 10, and the sum of all these mole fraction is equal to what? 1. Okay, that's about mole fraction. Once more, the mole fraction is the ratio between the number of moles of a particular component to the total number of moles. Then what is mass percent or weight percent? Yes, mass percentage means mass of solute to the total mass of solution into 100.